Hi guys, welcome back to my YouTube channel. This is Maunika, currently pursuing Computer Science and Engineering from Sri Venkateswara College. Course title Data Structure and Algorithm. Today I will discuss about significance of sorting and searching in data structure. Introduction. Search is a process of finding a value in a list of values. In other words, searching is the process of locating given value position in a list of values. Sorting refers to the operation of arranging data in some given sequence, that is, increasing or decreasing order. Sorting is categorized as internal sorting and external sorting. Internal sorting means we are arranging the elements within the array which is only in computer primary memory, whereas the external sorting is the sorting of elements from the external file by reading it from secondary memory. Search algorithms. Algorithm is a sequence of instructions or set of rules that are followed to complete a task. In the discussion that follows, we use the term search term to indicate the item for which we are searching. We assume the list to search is an array of integers. Although these algorithms will work just as any other primitive data types, we refer to the array elements as items and the array as a list. First, linear search. Linear search is one of the basic and simplest search algorithm, and it is also called as sequential search algorithm. It is used for unsorted or unordered small list of elements. In this technique, we search for a given key item in the list in linear order, that is one after the other. The item to be searched is often called as key item. Linear search algorithm finds given element in a list of elements with zero index. Time complexity, where n is the total number of elements in the list. Implementation of linear search. Following are the steps of implementation that we will be following. First, we will input the values such as int values, int key item, int n. First, transfers the array using a for loop. We use here for loop. In every iteration, compare the key item value with the current value of the array. If value of I is equals to key item, we compare here. If the value match, return the current index of the array. Return what is the index of the array. If the value do not match, move on to the next array element. Just go to next iteration. If no match is found, return -1. What is binary search? A binary search is a simple searching technique which can be applied if the item to be compared are either in ascending or descending order. The general idea used in binary search is similar to the way we search for address of a person in an address book. Obviously, we don't use linear search. Instead, we open the book from the middle and the name is compared with the element at the middle of the book. If the name is found, the corresponding address is retrieved and the searching has to be stopped. Otherwise, we search either the left part of the book or right part of the book. If the name to be searched is less than the middle element, search towards left, otherwise search towards right. The procedure is repeated till the target item is found or target item is not found. Implementation of binary search. While designing the program, the low is considered as the position of first element. It is initialized to 0. And high as the position of last element. It is initialized to n-1. Here, we initialize low is equals to 0, high is equals to n-1. The middle element position can be obtained using mid is equals to low plus high by 2. Here, we initialize mid. The target element to be searched is compared with the middle element. See, the item is compared with the middle element. If they are equal, the position of the item in the array is returned. Here we return position of the item is returned. If the condition is false, the target element may be present either left part of the array or in the right part of the array. If the target element is less than the middle element, then the left part of the array has to be compared from low to mid. Otherwise, right part of the array has to be compared from mid plus 1 to high. Finally, when the low exceeds the high, it indicates the item not found in the array. Till now, we have discussed about searching algorithms. Now, we are going to discuss about sorting algorithm. In that first one, insertion sort. Insertion sort is a very simple method to sort the numbers in an ascending or descending order. This method follows the incremental method. It can be compared with the technique how cards are sorted at the time of playing the game. Here, sublist is maintained, which is always sorted. For example, the lower part of an array is maintained to be sorted. An element which is to be inserted in this sorted sublist has to find its appropriate list and then it has to be inserted there. Hence the name insertion sorts. This algorithm is not suitable for large data of sets. Implementation of insertion sort. Following are the steps involved in insertion sort. First, we start by making the second element of the given array, that is element at the index 1, the key. Second, we compare the key element with the elements before it. In this case, element at the index 0. If the key element is less than the first element, we insert the key element before the first element. If the key element is greater than the first element, then we insert it after the first element. Then we make the third element of the array has key and we'll compare it with the elements to its left and insert it at the right position, and we go on repeating this until the array is sorted. Here is the function code. Void insertion, we insert int a and int length. For int I is equals to 1, I is less than length I plus plus, j is equals to 1. We give while conditions such as j is greater than 0 and a of j plus 1 is greater than a of j. Key is equals to a of j is equals to a of j minus 1. A of j minus 1 is equals to key, return j minus minus. Second, Quicksort. Quicksort is a highly efficient sorting algorithm and is based on partitioning of array of data into smaller arrays. Quicksort is a divide and conquer algorithm to gain same advantage as the merge sort while not using additional storage. Quicksort is often preferred over other algorithms like merge sort due to its efficiency in average case, smaller memory footprint, and speed for large datasets. Quicksort implementation. To write a quicksort method that splits the array into shorter and shorter subarrays, we use a recursion. This means that the quicksort method must call itself with the new subarrays to the left and right of the pivot element. To implement a quicksort algorithm in a programming language, we need an array with the values to sort, a quicksort method that calls itself if the subarray has the size larger than 1, a partition method that receives a subarray, moves values around, swaps the pivot element into subarrays, and returns the index where the next split in the subarrays happen. Here is the function code. Finally, I conclude. In this research paper, we have studied about different searching and sorting algorithms. Every searching and sorting algorithm has advantage and disadvantage. Some sorting algorithms have been compared on the basis of different factors like complexity, number of passes, number of comparison, etc. It is also seen that many algorithms are problem oriented, so we will try to make it global oriented. Hence, we can say that there are many future works which are as follows. First, remove disadvantage of various fundamental sorting and advanced sorting. Second, make problem-oriented sorting to global-oriented. The advantage of selection sort is that number of swaps is 0 and the disadvantage is that it does not stop early if the list is sorted and it looks at every element in the list in turn. It is suitable in the cases where you need to select max element in the list. With the time complexity same as bubble sort, its performance however is better than bubble sort. The advantage of quicksort is that it is fastest sort and is zero in both the numbers of comparison and the numbers of swap, and disadvantage is that algorithm is bit tricky to understand. Thank you. Don't forget to like, share and subscribe my video.